This is ME361 Thermal Fluids Lab. Today we're doing the cooling tower experiment. The purpose of this experiment is to demonstrate the design and operational characteristics of a modern evaporative cooling system. Airflow is going to be introduced by a centrifugal fan located here at the base, while thermal energy will be added by your heat source over here. It'll be measured by thermocouples throughout the system. You'll have wet bulb and dry bulb temperatures for the air up here, wet bulb and dry temperatures for the air inlet down here. You'll have your water inlet temperature located up here and your water outlet temperature located down here. The last temperature that will be recorded will be your makeup water temperature located over here. Also take note of the flow rate that will be measured by the rotometer here. The units are grams per second. Over here, your manometer at an incline is in units of millimeters water. And finally, behind the experimental unit is the NI-DAC, which can be seen here with each Type J thermocouple lead attached to the appropriate terminal for the acquisition of temperature data by the LabVIEW VI used in this experiment.
The next step will be to record data using the LabVIEW acquisition, and this is a two-person job. You will have one person running LabVIEW and you'll have one person over here judging the makeup tank. This person will place masking tape on the makeup tank and draw a line to indicate where the water level's at. The person running LabVIEW will tell this person to start, and they will watch the water go down in the makeup tank, and when that person says to stop, they will draw another line on the makeup tank to indicate where the water level dropped to. This is the LabVIEW program. You will start this by hitting the run button. Record all temperatures by flipping the data save switch on the LabVIEW control panel for 10 seconds. Record the total time shown on the LabVIEW interface. This value will be used to determine the average mass flow rate of the makeup water during the experiment in these tables right here. Record the pressure of the orifice differential after the airflow has reached steady state.
To begin the experiment, what you're going to need to do is make sure that the makeup water tank has a sufficient amount of water. You'll fill it up, honestly, probably about 3/4 of the way full just to get the experiment started. Through the course of the experiment, you're going to keep it full when you're not recording data. When you record data, you'll end up marking off 2 marks, and you'll record the difference in how much water it takes to fill up from one mark to the next. During the experiment as well, you also need to make sure that all your wet bulb temperature vials and thermistors have water in them. So you'll find them here as well as here. And what you'll need to do is you'll need to pull out the thermistor and fill this vial up with water, and you'll need to check this periodically throughout the experiment to make sure that it stays full so that your recordings are accurate. You'll put that back in there. To start the machine, once all the water is in there, you're going to turn the pump on, you'll turn the fan on, and for your initial setting, you're going to turn the water to 0.5 kilowatts. You'll turn that on. Then you're going to come over here, and you'll make sure that your fan, which has this disc to control the airflow, is all the way open. And so that's going to be your initial setting, and you're going to wait for a steady state, which takes about 7 minutes. Once that happens, you're going to record your flow rate and the pressure from the air.
Now that the first setting is complete, you're going to lower the disc and allow for partial airflow. You're going to make sure this line matches up with the back of the shroud. After this, you're going to let the system reach steady state, and you're going to record all your data. After that, you're going to come over here and add another kilowatt of power, totaling of 1.5 kilowatts. You'll then allow steady state to reach approximately 7 minutes, as mentioned before. You'll take all the readings. You'll then open up the disc and allow for maximum airflow. Another 7 minutes should be taken to allow for steady state, and you'll take all pressure readings. After this, you'll go in and you'll start turning off all components. You turn off 0.5 kilowatt and then 1 kilowatt power source. You also turn off the pump and the fan, and then you're done.